introduced with the program, and you can see that if you'd like, the right triangle, ABC, C is the hypotenuse. We dropped a height, an altitude, H, and then it split the hypotenuse into two things, P and Q. I'm suggesting make a little T showing this H and PQ, and you can see where H squared equals P times Q. Another one that we're going to have, and I'll use red here, is A squared is going to be, I like to make this in red. Here's P, Q, here's A. So A squared is going to be the adjacent leg to A, P times the whole length C, or P plus Q. That's the same as length C. And then the last one is B, and it's kind of the same thing. Here's your B, here's your Q, here's your P. This Q is adjacent to the B, so B squared equals Q times P plus Q. So this T, H squared equals P times Q. A squared is equal to P times P plus Q. And then B squared is equal to Q times P plus Q. Those are the formulas. I'm going to derive them, but it really helps to visualize these first. Okay? So let's do it. Would you draw on a blank slide A, B, H, P, and Q? I'm going to draw three. I don't need this that big. I'm going to draw three triangles. I was right. First one is going to be this one, which is H, P, and A. The next one is going to be B, Q, and H. This is a right angle as well. And then, of course, there's the whole thing. A, B, and P plus Q. And obviously, I'm going to play around with these angles. Let's call this alpha. And if this is a right triangle up here, what will this angle here have to be? From B and P plus Q, what will this angle have to be? 90 minus alpha. We're going to put that in here. Oh, this also will be 90 minus alpha. And this is going to be what? Alpha. So since we can see in all three of those, these triangles are going to be what? Similar. So write that down. Like it? Okay. So if they're similar, then the corresponding sides, are they equal? No, they're not equal. They are proportional. By the way, yeah, they're not congruent. So we can't do side, 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 or anything like that. All right, I'm going to put three ratios, P over H, and A over P plus Q, and B over P plus Q. And I want you to make some ratios with those. Okay, so here we go. You find those ratios and we'll talk about them. So did anybody get P So I'm going to highlight this. P is to H. P is to H. So what's that going to be equal to in this second triangle? What's that? H over Q. That's right, because P is the leg between alpha and the perpendicular, and here H is between alpha and the perpendicular. How about A is to P plus Q? So that's going to be this one. A is to P plus Q as what? What do you think? P is to A. Yeah, because A is to P plus Q. A is between alpha and the right angle, and that's what P is. So I'm going to put a P is. And then P plus Q is the hypotenuse, and in this case it's A. We don't want to use the one with the H in it this time because we're trying to avoid H. We're going to do the same here. Avoid H. So B over P plus Q is just going to be what? Q as to B, right? A little trouble with the syncing. So B is to P plus Q as Q is to B. So that works out great. So now you can see where these formulas come from. H squared is going to be equal to PQ. That was one of my formulas. A squared is equal to P times P plus Q. You saw that one coming. And then we have B squared is equal to Q times P plus Q. And those are the three Euler's theorems using a right triangle. Pretty simple to prove and pretty interesting to look at. Let's go right to the class problems and go to the one here. I'm going to start off by drawing this ABC, and we're going to split this into H, P, Q. And just remind you that we had H squared, which was equal to PQ. We had A squared, which was P times P plus Q. And then B squared was equal to Q times P plus Q. You get used to these formulas a little bit, but it really helps me to have these handy. So it says, find the length of QS and RS. Probably the only one that's going to work is this middle one, if you called this A and this one P and this P plus Q, right? So I would say that A squared equals P times P plus Q. A squared is 5 squared equal to P, which is SQ, times 13, right? So SQ is just going to be 25/13 centimeters. So if that's 25/13, how are you going to find H or SR? How are you going to do that? What do you think, Shane? Yeah, you can use the first one, for sure. Sure, SR squared is going to be equal to P times Q. So it's going to be 25/13, and then this is going to be 13 minus 25/13, right? Anybody have another way, a quick way you could do it? Pythagorean theorem? Is that what you were thinking, Oliver? Oh, absolutely. That would work as well. So you could also just say SR is the square root of 5 squared minus 25/13 squared. That'll work as well. Either way, there's going to be some yucky fractions in there, but you can figure that out. This one isn't too bad. 169 minus 25/13. What is that? 144. So this is 25/13 times 144/13. What's neat about this is what's the square root of 25? 5. Square root of 144? 12. Square root of 13 squared? 13. So this is going to be 60 over 30. Or 13. That'll be SR. So actually, Shane, were you the one who said this? Nice. I would agree. Use the h squared equal to p times q.